The sum of the cubes from 1 to n derived using the combination of numbers and shapes. First, let's break down the cube of 1 into 1 times 1 squared, which is equal to the area of a square with a side length of 1. Then the cube of 2 is disassembled into 2 times 2 squared, which is the area of 2 squares with 2 sides long. The cube of 3 is equal to 3 times 3 squared, which is the area of 3 squares with 3 sides length. The cube of 4 is equal to 4 times 4 squared, which is equal to the area of 4 squares with sides of 4. And so on until the cube of n is equal to the area of n squares with sides of n length. So the sum of the cubes from 1 to n is equal to the sum of the areas of all the small squares in the graph. So how should the area of a square be calculated? We can make a red straight line as shown in the figure. N small red triangles are divided into the upper right of the straight line. We rotate these little red squares 180 degrees clockwise, and the sum of the areas of all the small squares forms the area of a large triangle, and the sum of the cubes from 1 to n is equal to the area of the big triangle. The height of this great triangle is equal to the sum of the series of equal differences from 1 to n, which is n times n plus 1 divided by 2. The base edge of this large triangle is equal to n multiplied by n plus 1. So the area is equal to 1/2 of the base multiplied by the height. The final result is equal to n times n plus 1 divided by 2 squared.